Welcome back. Today we're doing another explainer, and we are diving into something that is honestly completely mind-bending. We're going to take a look at the true scale of everything that exists. We'll start right here at home and zoom all the way out into the deepest expanses of space. We're basically going to try and wrap our minds around scales and distances that, frankly, completely defy everyday human logic.
Okay, let's dive into this because this isn't just a spatial journey, it's a philosophical voyage of perspective. Usually I'd give you a detailed roadmap of exactly what we're covering, but today we're going to skip the usual agenda. I really want to preserve that pure, unadulterated sense of awe as we pull back the lens on reality. We are going to ask ourselves one fundamental question today. Just how small are we in the grand scheme of things? Prepare to be astonished because the sheer scale of what we're about to explore changes absolutely everything.
Section 1. Leaving our blue orb. Right. Before we can even begin to comprehend the universe, we kind of have to start with the familiar. We have to ground ourselves exactly where we are right now. So, step 1 is Earth, that familiar blue and green orb we call home. It feels incredibly massive to us, right? But as we take step 2, venturing just past our atmosphere to the moon, our closest cosmic neighbor, we start to understand distance in terms we can actually grasp. The moon is 250,000 miles away, making it our first real stepping stone. But then, step 3 takes us to the sun. And the scale jumps dramatically here. You could literally fit over 1.3 million Earths inside the sun. It is so incredibly far away that the sunlight warming your face right now actually left the sun 8 whole minutes ago. And we don't stop there. Step 4 pushes us out toward Mars, and then all the way out to Neptune. We are now traversing the dark, freezing outskirts of our immediate cosmic family, where the light from the sun takes over 4 hours just to reach us. Section 2, Reaching the Outer Limits. And this brilliantly illustrates where we are now crossing the physical boundaries of human influence. We're moving from distances we can somewhat imagine into this growing sense of absolute vastness. That number 1, that represents Voyager 1, humanity's farthest probe. Think about that for a second. Out of all human history, out of all our technological marvels, this single, lonely probe represents the absolute physical limit of where we have managed to reach out into the dark. Voyager 1 has been flying away from us at roughly 38,000 miles per hour since 1977. It's been traveling continuously for decades, and yet it is still less than 1 light day away. In the grand scheme of the universe, our absolute greatest technological achievement has basically barely left the front porch. So, pushing even further past Voyager 1, we hit the Oort Cloud. This is the enigmatic, massive outer boundary enveloping our entire solar system. And it isn't just a thin line. It is this incredibly thick, spherical shell of icy debris. To give you a sense of this boundary's sheer size, it's going to take Voyager 1 roughly 300 years just to reach the inner edge of the Oort Cloud, and possibly 30,000 years to fly completely through it. This is the true, mysterious edge. Once we've finally passed through this immense icy shell, we are officially stepping off the map and entering the sheer, unadulterated emptiness of the interstellar void.
Section 3, Sailing the Milky Way. Okay, we've bridged the gap to deep space, and we really need to scale up our thinking to a truly galactic level now. Once we're in the void, our next milestone is Alpha Centauri. This is our closest neighboring star system. Notice I said closest. Even though it's our neighbor, the distance here is where our human brains really begin to short-circuit. Alpha Centauri is over 4 light years away. If we boarded our absolute fastest modern spacecraft today, it would still take us tens of thousands of years just to reach it. It's a lonely, massive stretch of nothingness just to get to the house next door.
Now, what's really interesting about this is the contrast. It's staggering. On one side, we have the entirety of recorded human history. Every war, every triumph, every single empire you've ever read about spans roughly 5,000 years. On the other side, we have the sheer scale of the Milky Way. It takes light, literally the fastest thing in the universe, 100,000 years just to cross from one end of our galaxy to the other. That means a photon of light emitted from a star on the opposite side of the Milky Way began its journey toward us long before modern humans even existed. When we consider our position in the grand scheme of our galaxy, we kind of have to realize that our entire history is just a whisper in the cosmic wind. We are a tiny, almost imperceptible dot in a sweeping sea of stars.
Section 4, Superclusters and Great Attractors.
Let's move to and see how this builds, because we have to keep zooming out. We are now entering the macroscopic web of the universe. The scale we're dealing with now is so unfathomably large that entire galaxies exactly like our Milky Way with its billions of stars, now act as tiny, insignificant building blocks. We start with the local group, our immediate galactic neighborhood containing the Milky Way and roughly 50 to 80 other galaxies. But that group, it's just a minor component that gets completely swallowed up by the Virgo Supercluster, which is this expansive web containing thousands of galaxies. The structures we're talking about now are no longer planets or stars. They're massive, glowing collections of entire galaxies bound together by gravity. And if the Virgo Supercluster wasn't enough, it turns out we are just a minor branch within the Laniakea Supercluster. And I really want to emphasize the word staggering here. In Hawaiian, Laniakea translates to immense heaven, and it hits the nail right on the head. This staggering structure contains our Milky Way, the Virgo Supercluster, and roughly 100,000 other galaxies. It holds the mass of 100 quadrillion suns. The sheer, overwhelming scale of this colossal structure is almost impossible to picture, yet this glowing, vein-like web is simply the basic architecture of our greater cosmic neighborhood. But within this colossal architecture, we find things that remind us of our complete vulnerability. Enter the Great Attractor. This is a totally mysterious gravitational anomaly located deep within the Laniakea Supercluster, and it is exerting a massive, inexorable pull on our galaxy along with tens of thousands of others, dragging us all toward it at hundreds of kilometers per second. And the craziest part? Because it's obscured by the dust and stars of our very own Milky Way, we don't even know exactly what lies at its center. It really shows us just how small and susceptible even our grandest galactic structures are to the truly massive, enigmatic cosmic forces out there.
Section 5. Edge of the observable universe.
So, the crucial point is, we have finally arrived at the absolute physical limit. We are now confronting the boundaries of the observable universe. But it is vital to understand why it's called the observable edge. This isn't a physical brick wall floating in space. It is a wall of time. The universe is about 13.8 billion years old, right? Well, we literally cannot see past this boundary because the light from anything further away simply hasn't had enough time in the entire history of the cosmos to reach our eyes. From our familiar blue and green orb, past the lonely Voyager 1, through the staggering Laniakea Supercluster, we have reached the absolute limit of light itself. This entire journey has really been about humbling our perspective, marveling at the universe's grandeur, and recognizing our incredibly small, yet incredibly rare and special place within this beautiful system. And as we stand here, staring at the absolute boundary of everything we can possibly see, we are left with one final, humbling mystery that challenges the very limits of human understanding. What lies beyond?
Thanks for watching this explainer. I'll see you in the next one.